Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about relative velocity in two dimensions. Relative velocity is the velocity of a body relative to other body, or the velocity in which a body is appear to another body or a person. That means, you see this example. If a car is moving in this direction with a velocity v, a person is standing on the ground like this. For this person, this car appears that the velocity of the car, that is v, and another person is running in this direction. Okay, this. Okay. For this person, this car appears greater than the car velocity. Okay. So, another person, he is moving in this direction. Okay. For this person, this car appears that lesser than the velocity of the car velocity. So, from this, you see this three different cases. The velocity of the car is different. So, the velocity of an object varies from person to person based on the magnitude of motion and the direction of motion. So, we have introduced a concept, relative velocity. In the relative velocity, we are consider the earth is the reference, or ground is the reference, and the ground velocity Vg is equal to 0. All the body velocity is measured with respect to ground velocity. So, if a car moving on a road with a velocity of 40 meter per second, okay, this is a car, Vc equal to this. Okay, so the velocity of the car is the relative velocity of the car with respect to ground. Will represent it like this: Vcg, that is equal to velocity of the car minus velocity of the ground. Okay, so the velocity of the ground is 0, velocity of the car is 40. So 40 minus 0, so 40 itself. So the velocity of the car with respect to ground is 40 meter per second. So any person standing on the ground feel that the car is moving with a velocity of 40 meter per second. Okay, if two bodies are moving in a straight line, the directions are maybe along the same direction or in the opposite direction. But in the plane, the directions are not in the same or opposite. It may be making some angle. So that we will discuss here, the relative velocity in two dimensions. If a car is moving in this direction with a velocity v, okay, then another car is moving in this direction with a velocity v. Okay, so this is making an angle theta. These two are making an angle theta. Okay, so this is the velocity vector of the B object, and this is the velocity vector of the A object. In the plane, we are consider the velocity is a velocity vector. Okay, then relative velocity of the A with respect to B is velocity of the A with respect to B is VAB, that is equal to VA minus VB, that is VA vector minus VB vector. Okay, then this we can write like this: VA plus minus VB vector. What is this minus VB? minus dt vector is a negative vector of vb. Okay, so the relative velocity of the A with respect to B is the addition of velocity of the A vector and negative velocity vector of the B. Okay, so a person in the B looks A, he feels that A is moving with this velocity. That is the relative velocity of the A with respect to B. Okay, now we can apply the vector addition rules and we can find out this. Okay, so this we can change, I can change like this, negative vector. Okay, this way I can draw the negative vector. This is minus B. Negative vector having same magnitude but in the opposite direction. Okay, now I can form a parallelogram here. This is also minus. Okay, then this is VA. Okay, the angle between VA and VB is theta. Then the angle between VA and minus VB is 180 minus theta. Okay, then the diagonal is a resultant. So this is a relative velocity of A with respect to B. Okay, so this magnitude, the relative velocity of the A with respect to B magnitude is square root of VA square plus VB square minus 2 VA VB cos theta. Okay, this is the magnitude of the relative velocity. Then the direction of the relative velocity we can find out by finding the alpha angle. Okay, so this alpha is the angle made by the resultant with the horizontal. So tan alpha is equal to B sin theta divided by, that is B means VB. Okay, and VA minus VB cos theta. Okay, from this you can take the tan inverse of this, then you will get the alpha. Okay, this way we can find out the relative velocity in 2 dimensions. Okay, now we will see an important type of problem, rain umbrella problem. Okay, this is the important type of problem in the relative velocity in 2 dimensions. Okay, this is the problem. Rain falling vertically with a speed of VR. A woman rides a bicycle with a speed of VW in east to west direction. What direction she should hold the umbrella? Okay, so the rain is falling vertically downwards. Okay, with the velocity VR. Okay, in 2 dimensions we are considering the rain velocity vector. Okay, and the woman is riding east to west direction, a bicycle. So the east to west direction is like this direction. Okay, like this direction. The woman ride the bicycle with the VW velocity. Okay, so in this direction with the VW velocity vector direction. Here you see this. Here the woman and the rain are moving. So the rain appear to the woman is the relative velocity of the rain with respect to woman. So the woman keeping the umbrella in the opposite direction in which the rain appeared to the woman. Okay, that is the relative velocity of the rain with respect to woman. Okay, so we will see the relative velocity of rain with respect to woman. Is the VRW, that is equal to the velocity of the rain minus velocity of the woman. This I can write like this, VR plus minus VW. Okay, minus VW is a negative vector of VW. Okay, so Clear? Okay. Then here we can draw the negative vector like this direction. This is a minus b. Okay. Then I'm going to form a parallelogram here. This is also minus b. Okay. Then this is the VR, the rain velocity. So the resultant is the diagonal. This is the relative velocity of the rain with respect to movement. Okay. Then what about the magnitude? Magnitude is equal to square root of VR square plus VW square minus 2 into VR VW cos 90. Here you see that the angle between this and this is 90 degrees. So cos 90. Cos 90 value is 0. So this entire term is 0. That is equal to VR square plus VW square. This is the magnitude of the relative velocity of the rain with respect to movement. Then we need to find out the direction. The direction is, this is the angle theta made by the resultant with the vertical. So tan theta is equal to, if you consider this triangle, right angle triangle, for tan theta is the opposite side, VW divided by adjacent side, VR. Okay, so this is the angle. From this you can take the tan inverse. Tan inverse is equal to VW divided by VR. Okay, then now you see. Okay, so the rain appear to this woman in which direction? You see the rain appear to the woman is like this direction by making an angle theta with the vertical. Okay, actually the rain is falling vertically downward because of the woman is moving in the east to west direction. The rain appears like this direction. Okay, so she should keep her umbrella in the opposite direction like this. Then she is protected from the rain. Okay, by making an angle theta with vertical like this. Okay, so this is about this problem.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like